Hello everyone, welcome to this channel. My name is Ruben and today we are going to talk about the big ideas from ARK Invest from 2021. This series will consist of 15 episodes and this part will be about part 2, the reinvention of the data center. They argue that the data centers, the power of plans of computation are going through a revolution right now. Cheaper, faster and more power efficient processors are starting to displace Intel, which traditionally had captured over 90% of the processor revenue. For cloud computing, ARK believes that ARM, RISC-V and graphic processing units, also known as GPUs, are likely to emerge as the new powerhouse processors. Together they could scale at a 45% annual rate to 19 billion in revenue by 2030. And they also believe that in the data center, these accelerators dominated by the GPUs will become the dominant processors for new workloads, growing 21% at an annual rate to 41 billion by 2030. Let's have a look at the data center architecture. On the x-axis we have time and on the y-axis we have market share. If we look at 2000, we had a 77% market share for legacy such as Spark and Power. In 2020, the x86 architecture had a market share of approximately 92%. And if you look at 2030, ARK really believes that ARM and RISC-V, that they will capture market share, and they have a rough estimate of 71%. So the last great migration of the data center was from the RISC processors in the 90s to Intel's low-cost PC-derived x86 architecture, leveraging the scale of the computer market. Intel disrupted high-end incumbents. Today, ARM processors are leveraging the scale of the mobile ecosystem to disrupt Intel. Applying open source principle to hardware, RISC-V also is emerging as a standard in low-cost computing. And they believe that the combination of ARM and RISC-V will move from 0% market share in 2020 to 71% of the server market by 2030. So what is RISC-V exactly? Let's listen to the CEO.
RISC-V is a free and open instruction set architecture at the heart of the core of an SoC that lives on the board, that rests in the system, that then proliferates across software. RISC-V is driven through open collaboration. In fact, it is the most prolific open instruction set of our time. And this is fundamentally changing how the industry looks at building semiconductors. Once upon a time, you only had proprietary options. Yeah, a few open options started to make inroads into this space, but none really took off like what we're seeing with RISC-V. RISC-V fundamentally is changing not only the business model, but the technical model. And we are enabling the freedom of design without boundaries across all domains and industries. This is well on course to overturn and disrupt the entire industry. This is cementing the strategic foundation of semiconductors for this era, our next era of computing, on an open and collaborative concept. Let's start with the technology. RISC-V is fundamentally designed for a modular approach. Rather than layering additional extensions onto a base ISA, where many legacy ISAs have somewhere around 1,500 base instruction sets, the RISC-V approach takes 47 base instructions, and then you can modularly add just those extensions that are required for your design. The business model is completely overturned in that it is free. There's unlimited use, and you can implement this from anything from embedded to enterprise. It's growing rapidly, and we're seeing many new custom approaches to semiconductors coming with this.
Intel seems to be frozen in time. Once the world leader of semiconductor manufacturing, Intel seems to have lost its way, because Intel delayed its 10nm processor by 4 years, allowing its competitors such as TSMC, AMD to lead the market in 2020. And as of 2020, Intel has not yet shipped a 10nm server chip. A full generation ahead of Intel, TSMC is mass producing 5nm processors. And you can see that in the graph. On the x-axis we have time, and on the y-axis we have production node. And then you see a downward sloping curve with a purple color with a reference to Moore's law. And what is Moore's law about? It's named after Gordon Moore for his work in 1965, and it focuses on cost as a function of time. Specifically, it states that the number of transistors on a chip would double every 2 years. And to top it all off, last June in 2020, Apple has announced the biggest change heading to its Mac computers, namely dumping Intel. The company is ditching Intel's traditional so-called x86 desktop chips for Apple's own processors based on ARM's designs, and those are used in smartphones and mobile tablets, including the iPhone and the iPad. ARM could power the majority of developer PCs by 2030. Almost all software developers write code on Intel's x86 PCs running Windows, Mac or Linux operating systems, and Apple plans to transition Macs, which are used by 1 in 3 developers, from x86 to ARM-based central processing units, also known as CPUs, over the next 2 years. And at the same time, Microsoft is doubling down on its efforts to support Windows on ARM processors. You can put that in a graph. On the x-axis we have time, and on the y-axis we have a total market share of 100%. And in 2020 you can really observe that x86 has the majority of the market share with 99.9%. And then you can move to 2025, ARM is going to have a market share of approximately 60%. And by 2030 you can really see that they have like the really majority with a market share of approximately 82%. And x86 in 2030 has a market share of 18%. Also, ARM could become the next standard in the cloud. The public cloud, the default platform for deploying new applications, generated 140 billion in global revenues in 2020. Amazon Web Services, also known as AWS, the largest public cloud provider in the world, launched the Graviton 2 ARM CPU in 2020, reducing its need to purchase chips from Intel or AMD. You can also put that in a graph. You have performance times the cost per hour, and then you have the result. And the AWS Graviton 2 is cheaper and faster than Intel's CPU, offering 48% higher performance per dollar. Last September in 2020, Nvidia announced it wanted to buy ARM from SoftBank, and the deal is right now waiting regulatory approval. Let's listen to both the CEO of Nvidia, Jensen Huang, and to the CEO of ARM, Simon Segars, and they will talk about a possible business combination.
Why did you decide to buy ARM? Why now?
Rene, we would like to create the computing company of the age of AI. As you know well, artificial intelligence is the most powerful technology force of our time. For the very first time, a computer can run software that writes software by itself, write software that no humans can, and achieve results that are quite spectacular. And so what we'd like to do is to unite the world leader in AI computing and the most popular CPU company in the history of computing. And by doing so, we're going to be able to bring our capability to the ARM ecosystem. And ARM will be able to give our accelerated computing, AI computing reach like never before. And together we'll be able to create solutions that are going to be great for customers, whether they're in the cloud or in the edge or autonomous machines and robotics or personal computing. We'll be able to create technologies and platforms that helps everybody grow. And so I think everybody's going to be super excited about this.
It's a great answer, and I'm glad to be asking the questions and not being questioned today, so it's really kind of fun. So Simon,
hold that thought.
You mentioned in your keynote the importance of hardware and software running together efficiently to enable the technological advancements of the future. How do you see our two companies working together to be able to contribute to that?
Well, yeah, computers are useless without the software that runs on them. And we're envisaging a world where there is just so much more pervasive computing than there is today, that computing platform changing to being one largely CPU-driven, regular code, procedural code, to a world of AI where software is writing software, software is checking software, software is learning from data. And that is just a completely different programming paradigm. So the hardware and the software are going to come together in different ways. And I think between us, putting the strengths of the companies together, we're going to be able to address that. We're going to be able to put tools into the hands of developers so that they can take all this great compute hardware and create amazing products from it. The hardware without the software is useless, so we've got to make it really easy for those two things to come together.
That's a great answer. A lot of folks have really loved the potential combination of the two companies technically. But Jensen, there's been a lot of questions about ARM's business model, and we've talked to a lot of partners who have questions about what are the intentions for NVIDIA to continue that business model going forward, the ARM business model specifically.
I love ARM's business model. As you know, I think the genius of ARM was the invention of this super energy efficient CPU architecture combined with this business model of licensing and having the wisdom of creating this vast ecosystem of computer makers and chip makers in just about every industry on the planet. That vision took 3 decades to realize. And I love that. I love the idea. I love the business model. I love the ecosystem that's been built. And so we have every intentions of protecting it, nurturing it, and growing this business model. And in fact, I want to add more to the business model. One of the things that I really value about ARM is this network of partners and the ability of ARM to take what is very difficult designs and turn it into soft IP products that people could use. And it's something that I've always wished that we could do, and to take the NVIDIA architecture and to put it through ARM's network so that companies of all different sizes and shapes and different industries could take advantage of our IP and allow us to extend the accelerated computing vision we have to all the industries. And this is what we're going to do with our combination. We're going to combine two of the most vibrant, most exciting computing ecosystems in the world. The largest one, of course, ARM's ecosystem, and the one that is developing very quickly with artificial intelligence, with NVIDIA's platform. And so we're going to be able to bring the NVIDIA developers to the reach of the ARM ecosystem, and we're going to add to the ARM ecosystem this exciting new capability called accelerated computing and AI. And so the developers are going to love it. That's ultimately, what they wish to have is a great platform with rich tools, but most importantly, that it has to be vibrant and rich and growing.
Both companies have talked a lot about AI, and AI being really part of the visions for what both of our companies will be doing in the future. Now thinking about a combined ARM NVIDIA, how does that change at all? And I'll start with you, Jensen, relative to how you think about AI in a combined ARM NVIDIA world.
Yeah, this is really exciting, and this you've heard Simon talk about this, and I've heard him talk about it publicly now for several years. We know that there's a whole new world of computing that's about to happen. Some people call it edge, some people call it IoT. The confluence of a couple of technologies are making it possible now for us to create autonomous, intelligent computers or machines that are doing skills all over the world. It could be driving a car, it could be driving a truck, it could be moving crates around in a warehouse, it could be doing fast checkout, it could keep keeping cities safe and keeping traffic flowing. It's almost as if the city is smart. It's almost as if the warehouse is smart. It's almost as if the retail store is smart. Now, that software that makes them smart is called artificial intelligence, and no human knew how to write that software until recently. We've now made it possible for us to create computers, develop softwares that write the software. Now that the software is ready, now that the software is possible, we realized that we're reminded of the fact that we're computer engineers and computer science enables new markets, but it's up to the software developers that create the growth. Well, for the very first time, the engine of that growth is going to come from a piece of software written by a machine. Well, machines can write software a lot faster than we can. And we now know that the machines can write software that we know we can't write. And so for the very first time, it's now possible to imagine a world where we're creating these autonomous systems and computers all over the world. It's helping society perform all kinds of tasks. The software is being written by another computer. And so the expansion of computing over the next decade is going to be far, far greater than the expansion of computing over the last decade. That's the exciting part. That's the reason why the combination makes so much sense. NVIDIA has deep artificial intelligence capability. We know how to write the software of artificial intelligence. No computing platform has the reach of ARM ever created. And so the combination, I think, is just incredibly powerful that way.
Simon?
Yeah, I think it's about delivering on that vision. When you think about it, AI has kind of grown up with huge data sets running in the cloud. We've been enabling endpoints and client devices. If you try and take all the data from the edge of the network and you put it in the cloud and you do something with it and you send an answer back, that is massively inefficient. So computing and AI computing has got to go to where the data is. And that's what I think we've got an even greater chance of delivering on through the combination. Worrying about where the data lives, how we run and manage the software, where the compute is. It's going to be a vast network of computers in the future, and we can deliver on that.
ARM and RISC-V could become the new processor standards by 2030. ARK believes that PCs and servers adopting ARM processors will create the first ecosystem with enough scale, tooling, and vendor support to challenge Intel's x86. ARM server revenue could 100-fold from less than $1 billion in 2020 to $100 billion in 2030, a level higher than x86 today. And RISC-V could make a meaningful contribution during the same time. And you can see that in the graph as well. The purple color is ARM RISC-V. ARK expects that will expand dramatically. Like mainframes, installed x86 compute capacity could continue to grow, but its revenue base could be cut in half. By 2030, the accelerator should replace the CPU as the main server compute engine. Accelerators such as GPUs, tensor processing units, and field programmable gate arrays perform the most demanding computing tasks, including artificial intelligence, analytics, drug discovery, and cloud gaming. Despite intense competition, ARK really believes that the GPUs will continue to dominate the accelerator market during the next 5 years, thanks to their unmatched programmability and software stack. You can put that in a graph. On the x-axis we have time, and on the y-axis we have server bill of materials in billions of US dollars. First, the CPU is going down from $30 to $27 billion with a minus 1% compound annual growth rate, and the opportunity here is for the accelerator, which has a purple color, and that's going up from $6 to $41 billion with a 21% compound annual growth rate. Sizing the opportunity. The bottom line here is that ARK believes that the server processors will transform in the next decade, and the opportunity here is for ARM and RISC-V. If you look at the data center CPU revenue in the graph, we have the x-axis, which is time, and the y-axis stands for revenue in billions of US dollars. The black bar stands for x86, and the purple bar stands for ARM and RISC-V. And ARM and RISC-V are likely to displace Intel's x86 in the cloud. Together, they could grow 45% per year to reach $19 billion in CPU revenue and $100 billion in server revenue by 2030. If we move more to the right, you have data center accelerator revenue. The axes are the same. The black bar stands for CPU, and the purple bar stands for accelerators. And ARK believes that accelerators dominated by GPUs will become the dominant processor in the data center, growing 21% at an annual rate to $41 billion in 2030. Thank you everyone for watching this video, and see you on the next part.